The Snapmaker Artisan is an all-metal, large-scale, 3-in-1 3D printer, laser cutter, CNC router. At just under $3,000 though, is it right for you, or would you be better off buying 3 separate machines instead? I'm James Bruce, you're watching MakeUseOf.com reviews. Keep doing that. Initial impressions of the Snapmaker are incredible, with everything well packed and in clearly labelled boxes, but it is a huge delivery and you might be blown away by the sheer number of bits here. I swear half of the weight comes from the packaging alone. For instance, Snapmaker provides a cute little toolbox where a handful of tools are neatly laid out in their own foam cutouts. It's really nice. But said box is then packaged in its own card box with another inch or two of foam around that. Another box measuring 4 by 3 by 6 inches contains a single pair of plastic safety goggles, which is then packaged within the overall packaging box. It just feels absurdly excessive. Apart from anything, the remaining box of boxes is about 1 meter cubed of space, and I don't know many people who have space to store that. Okay, so this is a long review and I'm going to break it into 4 parts because basically there's so much to cover. Starting with an overview of the build process and design of the machine, a higher level overview sort of thing, then we'll get into each of the 3 functions in more detail. So I started filming the construction of the main machine, but when it got to the acrylic enclosure, it got so tedious I couldn't have stored that much video, frankly, so I gave up on that. I would say it took me at least a few days of on-off construction, and I needed a second pair of hands to move it anywhere. It is not easy to move the machine at all. Once the enclosure is on, you need to remove that back panel and then pull the cables out. So I'd suggest actually building it wherever its final home is going to be. It's actually so wide it barely fit through our internal door frames. One thing that was clear to me throughout the build process is the incredible quality of all of the components here. It is by far the most well-made 3D printer I have ever built, with every part feeling solid and premium. The machine construction is fully metal, which is of course very heavy but also very sturdy. Each axis is controlled by custom linear modules, which are also enclosed with no exposed beams or bearings. To be honest, I've not come across this style design of axes before, but the internals have a light sheet of metal protecting them and the moving parts slide underneath these. It's a really innovative design. Maybe I'm naive to industrial machines. It's definitely not something I've seen before though, but very cool. Now the Artisan comes with 3 different build plates and tool head combinations, and they all swap in and out really easily. The build plates then sit on top of this extremely sturdy one-piece die-cast base plate. The 3D print plate is even double-sided, with one completely glass for a very smooth surface on your prints, and the other a textured PEI surface. More on tool switching later when I get to the actual testing of the machine. So the build area, as you can see, is enormous. It is by far the biggest machine I've ever tested yet, at 40 centimeters cubed. So that's enough to print, say, a full-sized human helmet. Now, it also comes with an expansive enclosure, as you can see, and this is what really makes the overall size of the machine so huge. So big, in fact, that I had to completely rearrange my office workshop just to accommodate it. These shelves it's sitting on are 60 centimeters deep, almost desk-like, and I needed 2 of them, one in front of the other, to accommodate this. I thought I was smart getting these deep shelves, not deep enough. It won't actually fit on your average desktop, so you do need to be careful and consider where exactly you're going to put this. So the main enclosure, including 2 rolls of filament on either side, measure up to about 90 centimeters wide. And building it without the enclosure is an option, I guess, but if you're buying this, it's because you presumably also want to laser engrave, which you do really need the extractor fan for. Moreover, you'll get worse quality 3D prints if you don't have that enclosure, so despite the marketing images showing it enclosureless, I don't think that's really viable unless you already have a large fume hood cupboard to put it in. The case is laser blocking brown acrylic, and it even includes a set of white LEDs, so you can clearly see what's going on when the door is either open or closed. You can set it to pause when the door is open. I've not done that for the sake of ease of use. I don't have small children or anything running around. As I mentioned, there's also an extractor fan with a hose included. It's not super long, but you can always extend it if needed. I have it just going out of the window here. In my experience, by which I mean once I figured out how to turn the thing on, it does a really good job of taking the fumes away and minimizing the overall smells that will end up in your home or workshop otherwise. But it's not just the enclosure. The Artisan also has a large control system attached to it with a massive bundle of cables that goes to the back of the machine. And this also acts as a power box. Now, this is far more than your average 3D printer control module. It features, again, a full metal case, a 7-inch color touchscreen, USB ports on both the side and the back, Wi-Fi connectivity, and it's easily the most easy to use control system I've ever seen. It's very explicit with its instructions because it can be. It has such a large screen area to tell you exactly what to do if you need to manually change something. It does need a few enhancements, like 3D model previews are still not working, but I expect those will come in the final firmware releases. The biggest takeaway from the design aspect that you should know is that not only do you need a lot of space for both the enclosure and the large control system, but then you also need the box of different build plates and tool heads and tools. It may be space-saving compared to 3 different industrial-sized machines, but it's not by any definition compact or desktop-sized. Okay, onto 3D printing. So the 3D printing aspect of the Snapmaker Artisan is probably the one we're all most familiar with, and there's no surprises here. It's a dual extrusion printer with 2 print heads which can be independently heated, and a motor inside the single tool head which deals with lifting each one up. It can print up to 300 degrees Celsius, so there's no material it won't be able to handle. It also auto-detects the hot end type, and while there are no alternatives at the moment, I assume at some point they'll sell, say, larger 0.8mm rather than 0.4, larger extruders. Now, in the past, I've had no end of issues with these pseudo dual color printers in that they would both feed into the same hot end. So loading filament was really annoying. You had to reset the first filament each time. You'd get an error if both of them tried to extrude at once while the hot end was full. It's not pleasant, and I've completely avoided dual color printers since, just because it was so annoying. But this completely eliminates any frustrations. It has 2 completely independent hot ends. Each is fed by a Bowden tube, which leads through the case to the filament holders on the outside. In terms of filament storage, there's nothing fancy there. It's just a metal tube on the outside of the case that the filament slips onto. So there's no heated or dehumidified enclosure, as you might get with some fully enclosed, more industrial models. Now, when 3D printing with the Artisan for the first time, you'll need to install the tool head and the heated bed, and remember to connect up the cable at the rear of the bed so that actually works. It's remarkably easy to swap out the tooling. It all uses the same toolhead cabling, except for the heated bed, of course. That needs power, and when you remove that, you should use the rubber cover to ensure the contacts don't get dirty from wood shavings if you're swapping over to that tool. But basically, swapping over the beds and tools takes less than 5 minutes total, at least from a hardware perspective. We'll talk more about the software later. The filament loading and unloading process is much as you'd expect with a Bowden tube. You'll need to feed it in by hand for about ½ meter or so. Our Artisan shipped with a black filament and a breakaway white filament, which isn't something I've used before, but it seems to just be a low quality sort of recycled white filament. So it preserves your precious, expensive main filament when doing supports. I also tried to use it to do some basic dual color printing, just white lettering on top, but it didn't really work for that. So, I mean, I wasn't expecting it to, but I thought I'd try anyway. The Artisan has various calibrations that are, for the most part, automatic. Has bed leveling with up to 81 points using a kind of BL touch sensor rather than inductive probe. Since there are two hot ends, you also need to calibrate the Z offset between the two, and finally the XY offset, which requires a quick test print comparison between the two and then a sort of final check print. This is the only manual part of calibration for 3D printing anyway, but you will need to do the automated Z offset and bed leveling every time you change back to the 3D printer tool. As expected, it also features a filament runout sensor, though I haven't tried to deliberately trigger that yet. One little feature I liked was the choice to not heat the entire print bed. You can choose for small objects to only heat the middle area, so that saves on your total power usage. Now, when I started reviewing this, the 3D printing features were not yet supported by the official Luban software, so I used their provided Cura profile instead. Now, first things first, the most important thing for any 3D print is the first layer, the adhesion, and my results on this front were incredible. The PEI coated glass bed is going to give the best results. Leveling is superb. I had gorgeous first layers and no warping at all. Of course, the enclosure is a great help there in that it completely prevents drafts from spoiling the temperatures. So very impressed overall on that front. As mentioned, I was also supplied with a roll of white breakaway filament, which is interesting. Probably not something I'll use much though. It does seem to remove easily from flat areas, but when I tried to, for instance, print a Lego ornament to test the tolerances, removing the support stuff from the base where it had stuck around the brick studs was an absolute nightmare. However, I'm pleased to report that the tolerances were great. Minifigures stuck down well, so dimensional accuracy seemed to be good anyway. The dual extruder does also support things like PVA and HIPS and other dissolvable filaments. So while I haven't had a chance to test that yet, it means 3D printing complex geometry should be possible. Next up, I tried this useful little print to identify metric bolts, and in this case I tried to use the breakaway filament to do the lettering on top. Didn't really come out that well. Not that I was expecting it to. It's perfectly usable, but obviously breakaway filament is not just another white filament that you can use instead. That was just me being lazy. I mean, it worked, but it's not great. There was also a bit of pillowing on the top, so I opted to increase the top layers for the next prints. Like any printer, there is some degree of tweaking. You won't get perfect prints out of the box. I also printed this puzzle toy to hold Christmas money for my 8-year-old. Really smooth action, so I'd say that was a success. Hiding his Christmas money in this was absolutely hilarious. Just don't ask me to try and get it open again. Then I went bigger. I packed the print bed full for a toilet roll holder for my son's room and one of these neat marble toys that were doing the rounds a few years back. The benefit of having a large print bed, of course, not just being able to print large objects, but also to load it up and print multiple smaller objects for more efficient use of the printer. Those were printed without support, so nothing from the breakaway white stuff to demonstrate there. I also wanted to use the dual color print head for sign making, so I swapped over to a pink PLA and did this one. Much better results here, very clean, I thought, and definitely something I'd like to explore even bigger signs for. Finally, I tried PETG, and the results were much more frustrating on this front. Again, I think this is a case of the profile not being fully fleshed out yet. I've not had any out-of-the-box issues with PETG printing before, but I just couldn't get it to stick. After a few hours, it would come unstuck and be knocked off. There were also some weird G-code bugs from Cura where it was using printhead number 1 rather than 2. I'm not really sure what was going on there and whether the fault lies with the Snapmaker or Cura, but I was able to fix the G-codes manually and eventually lowered the printhead for more squish, raised the temperatures right up, and was finally able to print well with PETG. But definitely more frustrating, I would say, than I have had with other printers out of the box, even much cheaper beginner level printers when it comes to PETG. Overall then, for 3D printing, I was very impressed, but with mixed results in some cases. The true dual extruder system is very useful. The print beds provided are fantastic. The first layer adhesion was mostly great, except for, as I say, with PETG. While I won't say the prints were perfect, obviously there's still going to be some degree of tweaking. I did generally find it to be very reliable. pretty much a case of hit print and go. But I'll end this by just reminding you that this is a preliminary Cura profile I was printed with and is provided with early firmware. I expect those things to get better with more options on that front as the Artisan gets closer to final release. So just something to bear in mind there. Still, a solid foundation to work from and definitely has the potential for outstanding results once things are dialed in. Okay, so then we turn to laser cutting and engraving. Before use, you'll want to swap over both the tool head and the print bed, and you should replace the rubber cap on the heated bed cable and tuck that out of the way. If this is your first time moving away from the 3D printing module, you'll also need to fit some clips to the side of the machine into which the Bowden tubes will then sit out of the way. The physical process of swapping tools over is very little effort at all. Just unlock, slide it out, and then same with the bed. However, every time you do this to the laser engraver, you'll also need to calibrate the height of the bed and the camera. This isn't optional, and it's similar to 3D printing with a manual bed leveling, with one point in that you push a calibration target under the print head and then move it down until you feel a slight bit of friction. Then you also need a blank bit of paper for the laser to burn onto, and you need to fix that paper down to the bed to avoid it blowing or moving away. It's an easy process, though a little bit tedious. The machine will walk you through the whole thing, but it's just a bit annoying to have to do if you're switching tool heads a lot. It also highlights one of the issues of using what is essentially a 3D printer as a laser engraver, in that you'll need to secure your workpiece to the bed each time, because of course the y-axis moves back and forth, while a traditional laser engraver, only the head itself moves at all. Your work is untouched other than by the laser, of course. It's a bit more effort, basically. For your first burn, I would strongly encourage you to go through the Quick Start Beginner's Guide, as it will walk you step by step through the many quirks of working with the Snapmaker Luban software. But essentially, you're going to use the laser tool to set out your paths and speeds, the strengths of the laser, etc. Then you're going to export the G code. The easiest option is to choose to load that code into the Luban workspace, though you can save it on a USB file. But if you load it into the workspace, you can then connect over Wi-Fi, and you get a preview of what's going on. So these are two separate and distinct parts of the Luban software package, and it can feel a little bit disjointed at times. My first burn with the demo file into 2mm balsa wood was very successful. However, I did need to leave it running for 10 minutes or so afterwards because the enclosure was so full of smoke. At which point I realized I had forgotten to turn on the extractor fan because it was manually disabled for 3D printing, and annoyingly, that doesn't turn on automatically. So initial results from the laser engraving and cutting were fairly promising. It has a built-in library of good settings to use for, say, engraving vegetable leather, cutting, or engraving balsa wood, and for the most part, focusing is automatic, or you can opt to manually do that by telling it the height of the material. Now, I also burnt a variety of cute rabbit decorations for the Chinese New Year. These came out great mostly, but for some reason the outer edge here just didn't cut, even though everything else on the design cut perfectly. Bit bizarre. I also tried cutting 3mm pink acrylic, and while it does have built-in settings at 120mm per minute for black acrylic, I had to slow that right down to 80mm per minute and then do 3 passes just to get it to cut. But that worked cleanly. I mean, it shouldn't be hard to cut this for a 10-watt laser, but that doesn't mean that 10-watt lasers always do that. So this performed pretty much as expected, I'd say, and it definitely helps having that extractor fan to take away the toxic fumes. Finally, I tried etching on a piece of slate, 80% power, 2000mm per minute. That came out pretty well as well. At this point, I'd like to say, if I'm honest, I'm not a huge fan of the Snapmaker Luban software. It feels too fiddly and it doesn't automate enough. I'll keep using it because it integrates all of the functions of the Artisan in one place, and I do hope they can improve upon it. Camera calibration, for instance, when using the laser head, should be automated. The calibration points should be clearly marked on the laser bed, and it should be able to see those, then use an algorithm to figure it out. You really shouldn't require user intervention at any point for that sort of thing. And yet instead you have to put a piece of paper in there, burn a square on it, tell it to take a picture of said square, manually mark out the corner of the square, clicking however many times. It's all too manual. Every single time you change to the laser tool head, you need to redo that step. It's just not that user-friendly, and hopefully they can automate that, because it's basically a solved problem at this point. And competitors that feature a camera don't need such tedious calibration steps. One other minor point is that you also can't access the camera feed if you've plugged into the control box over USB for some bizarre reason, only if you're using it over Wi-Fi. And it's not particularly high resolution, again, compared to some cheaper competitors that also happen to feature a camera. Still, fundamentally, the 10-watt laser burner and engraver works nicely. It's just a bit tedious in places. Finally, let's talk about the CNC then. So this is something entirely new to me, and I won't be going very in-depth here at all. I tried the test project though, and the capabilities are certainly promising. Again, switching to the CNC head is very simple. You swap over the build tray to this wooden one fitted now, and that has a series of bolt holes to attach clamps to. This is pretty much considered a consumable because sometimes you're going to be routing through the original workpiece and actually into this. You're going to cut holes in this. You could use a piece of scrap wood underneath to try and extend the life, but it's like $25 to replace, so it's not a huge expense if you do happen to completely mess it up. The CNC head is supplied with 3 drill bits, a thick one for general purpose wood, a thinner one for plastic, and a chiseled one for anything else. So once you've fitted the CNC head, you'll be using a couple of spanners to securely attach the desired bit. It's all very easy to set up. There's no complex calibrations on this one. Just plug it in. Now, the way CNC works is that before pressing start on any project, you're going to manually move the CNC head to the work origin 0 point, just above your material. So you use, again, the same sort of method as leveling a 3D printer head, essentially. Put a thin calibration card to get the head in place so it scratches the card ever so slightly, and usually that'll be in the center of your work. You can then also do a boundary check if you move the head up a bit, so similar to a laser engraver, just to ensure that it fits within the work area. And one other thing to bear in mind is that you will need your work to be very secure using these clamps. Unlike 3D printing, you really should stay by the machine as it works in case you need to hit that emergency button, because this spins very fast and can potentially catapult pieces off when they get cut out. So the CNC bit then spins and cuts into the material layer by layer, working much the same as a 3D printer, only in reverse, and the process being subtractive, taking material away rather than additive. One other thing to bear in mind is that it is incredibly messy, and things like MDF dust can be toxic, so you might want to wear a mask. Do not turn on the extraction fan, because you're just going to make a mess of things and gum it up. Also, don't use a regular household vacuum, because you will break it. They are not designed to suck up dust. You will mess up the filter and someone will be very angry. So you'll need to invest in some sort of shop vac, which is rated for dust extraction, which of course I only realized after cutting the first model out of MDF wood. In terms of quality, I mean, it came out really well, I thought. There were a couple of bumps on the bottom layer. I believe these are to prevent the pieces flying off, though in fact one of those pieces did go flying off, which is why you need to keep the door shut. So this was just a very simple vector cut through, which could be used in place of, say, laser cutting if the piece is just too thick to cut through with the laser. It's not a complex cut, it's just some quick lines, and took maybe 5 to 10 minutes to get through all that. I also wanted to try something more intricate, and for this I turned to an STL I bought off Etsy, dragon carving. Now, unlike the test file, which is just vector lines, an image relief map or STL file must be done line by line, similar to laser engraving an image, but in this case you also then go back and do the next layer line by line. So the amount of time taken is immense. This one took just over a day, and it's only 10 centimeters wide, plus I used the wrong bit. So you can see that it's lost all detail whatsoever. It turns out that you need to use the V-shaped bit for relief cutting and use this straight one for just plain deep line cuts. I should have realized that, my fault. I'm planning on redoing this much larger on a plank of wood, but I dread to think how long that will take, especially with a smaller bit, and for the purposes of this review and my electricity bill, I just don't have another week to let it run continuously. So it is what it is. Imagine this, but more detailed. So, Snapmaker Artisan. Is this the ultimate maker machine? The Snapmaker Artisan isn't cheap, but it is an incredibly versatile machine. It's ideal for the more demanding maker or small workshop that could make use of a variety of machine types without having to invest and learn potentially separate systems. For the same price as the Artisan, though, at around $3,000, you could definitely buy a large format 3D printer and a large format laser engraver, plus enclosures for both of them. But you probably wouldn't get nearly the same sort of industrial build quality that you have here, nor would you get any of the CNC functions. It does feel to me like the CNC aspect of this is more niche than the laser engraving or printing, but there are a lot of times I've thought, well, I could engrave this, but it would make more sense just to cut it out with a CNC if I could. However, the Snapmaker Artisan is not perfect. My experience with it has been somewhat marred by the occasional frustration. Whether that's having to type in a safety password every single time I turn the machine on with the laser module attached, because obviously a 10-watt laser module is far more dangerous than a 230-degree hot piece of metal or a spinning drill attachment, even though the laser literally won't turn on without the enclosure door closed, or the random errors that have been appearing for no reason. Again, prototype, early stage software. On top of that, the Luban software is not as user-friendly as other machines I've tried, or even Lightburn. It has quite basic features, yet still manages to somehow complicate the entire process. There are too many things that can go wrong, and it might just be an inherent design flaw with the Snapmaker Artisan trying to do so much, and the software that tries to do 3 different functions at once without really excelling at any of them. That said, the hardware itself is very solid, and I'm confident they can refine the software in time. User interfaces are always easier to iterate and fix than a fundamentally broken piece of hardware. And it is an incredibly powerful bit of kit in the right hands. It's a versatile system that will do any number of jobs in your workshop. I will, however, say, consider if you do need something, well, I want to say compact, but it's not compact at all. It's enormous, but it fits 3 machines worth of hardware into the one enclosure. However, given how long some of the functions can take to run, you may find you're better off with multiple, perhaps smaller machines that will suit your makerspace better for the same overall price. The bigger consideration is if you actually need all of the functions. If you don't need the CNC and won't use it at all, it doesn't make sense to buy this. There are compromises to making a multifunction bit of hardware. For instance, the laser engraving, although 40 centimeters squared seems like a large work surface, it's restricted to that because it has to fit within the enclosure. Whereas if you don't need that enclosure, you could be working with significantly larger pieces of wood by having a frame-style XY axis only laser engraver, which you can fit something underneath, put that on top of it. Or if you do want the enclosure, you can get a roughly similar working area in something like the X-Tool M1 and have far superior software, automated focusing and alignment, etc. So there are some compromises to be made by fitting them all within the one machine. Anyway, thank you to Snapmaker for sending over this absolute beast. I hope my review has helped you to know a little bit more about the Artisan and what it's actually capable of. Apologies if my CNC skills are not up to scratch. This has probably been one of the most difficult reviews I've ever done, and it's literally taken months to finish up, so hopefully it's helped you in some way. For more reviews, gadget giveaways and more from all of us at makeuseof.com, consider subscribing. For now, I'd love it if you could hit like. Until next time.